Hey, Algebra 2 friends, here we are looking at section 7.4, the remainder and factor theorem. So these are big deal theorems in and algebra, pre-calculus, and all of that stuff. So let's get started. Synthetic substitution and a depressed polynomial. So let's start with synthetic substitution. You remember synthetic division, right? So synthetic division, synthetic substitution are extremely related. So synthetic substitution basically says this: if you have some function, or basically is this, if you have a function f of x is equal to, let's say, 4x to the third power plus 2x to the second minus 3x plus 1, got something like that, and you wanted to figure out what f of 2 is. We know how to do that. We would do 4, multiply it by, multiply 4 times 2 to the third minus 2 times 2 to the second minus 3 times 2 plus 1. Figure it out. You got f of 2. Got it. But the other way of doing it with this process called synthetic substitution is like you would do with synthetic division. Okay? So what you do is you plug a 2 in right there. Remember this process? We wrote all the coefficients down of the polynomial, each of the terms in descending order. We got to make sure, like if this did not have an x term, we would have to put a 0 in for it. So we have to make sure that every degree is represented. Since every degree has a non-zero coefficient, I don't have to add a 0 in there, but if I didn't, I would. You know what I'm saying? And then you drop the 4 down, multiply by 2, we get 8. Add those together, 6, multiply by 2, we get 12. Add those together, we get 9. Multiply by 2, we get 18. Add those together, we get 19. Remember last time when we did this, we would kind of throw away the 19 and say, or use the 19 as, oh, the factor didn't divide evenly into it. Now, this is the only thing we care about when we're doing synthetic substitution. We just now know that f of 2 is equal to 19. Kind of slick, right? So that's what synthetic substitution has going for it. Depressed polynomial is a polynomial such that when you divide out one of its factors, the answer you get is called a depressed polynomial. So I'll show you. So if I were to give you this function, f of x equaling the following, x to the fourth power plus 3x to the third plus 3x squared plus 1, and I were to tell you that x plus 1 is a factor, right? And ask you to find the depressed polynomial, you would divide x plus 1 into this f of x to get a quotient, to get an answer, and that would be the depressed polynomial. I'm going to, for kicks and giggles, do this using synthetic division. So you remember synthetic division, when you look at this value that you want to divide into this polynomial, you're going to look to see what's going to make it 0. And what makes x plus 1 0? -1. So you got to put a -1 there. And then we plug it in and we drop the 1. And then we have a -1 here because we multiplied -1 times 1. Drop the 2, multiply that, -2, add that together. I get a 1. Multiply that, I get a -1, and I get a 0. Couple things happening here that I want you to see. I said that the reason why we were doing this is because we knew that x plus 1 is a factor. We can tell from long synthetic division, that this being 0 means that there's no remainder and that this is going to be the quotient, the answer. So the depressed polynomial here would be, so this is the remainder, this is the constant, this is the x term, this is the x squared term. So x squared term, like 1 times x squared plus 2x plus 1. So this is the depressed polynomial that we're dealing with. Here's what I want you to see though. Basically, x plus 1 is a factor of this polynomial. Since x plus 1 is a factor of this polynomial, it makes sense that when I put a -1 in, let's think about it in terms of substitution. If I substituted a -1 into this polynomial, I would get 0. Because one of the factors is x plus 1, and when I put a -1 into x plus 1, I get a 0. So if 0 is a factor here, that means when I plug 1 in, I'm going to have that 0 factor come to life and take care of this whole thing. Does that kind of make sense? Hopefully it will as we keep going. Let me know. I don't mind chit-chatting with you if you want to discuss. So example 1 has us doing synthetic substitution, which we've already done. We're like professionals now. of the value f of x is equal to, f of 6 rather. So we're going to put our 6 here. We'll do our 2, 5, 8, and 7. I left this big gaping hole because I'm hoping that you see that we need a cubed term. So I'm going to put a 0 there, okay? So we need that placeholder. We need to go in descending order and make sure that no value is missed. So now that we've done that, we're going to drop the 2, multiply, get 12. Add that up, we'll get 12 again. 6 times 12 is 72. When I add that negative 5, let's see how quick I am. I think I get a 67. 6 times 67, I'm going to pause, do my calculations, and then I get a 402. Let me get this here. 402. I'm going to add those together, and I get 410, right? When I multiply 6 times 410, 6 times 0 is 0, 6 times 1 is 6, 6 times 4 is 24. So I have 2,460. When I add 7 to it, I get 2,400. It's like subtracting 7 really, adding a negative 7, I should have said 53. Does that make sense? So if I were to plug 6 into this function, I'd get this. I don't know if you think that it's easier, that this synthetic substitution is easier than just plugging it in, but sometimes it's kind of neat. It kind of works out a little bit better than, kind of working through it. But if you like substituting back in there, you can definitely do that. But if on an assessment you're asked to use synthetic substitution, I do want to see that you can do that. So this key concept gets to the heart of what we were talking about in the vocabulary. X minus a, if that's a factor of some polynomial f of x, then this is true if and only if f of a is equal to 0. I'm going to say it again. If you have x minus a and it's a factor of f of x, meaning f of x is equal to x times x minus a times some other stuff, x squared, blah, 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 right? This can only be true. This can only be true. X minus a can only be a factor if when I plug a into f of x, the whole thing ends up being 0, which makes sense. Because if I put a into this part of the function, this part of f of x, they cancel out. Boom, I got 0. The other stuff doesn't matter. So this is the factor theorem, and it is wise to memorize it and make sure you understand. So when using the factor theorem in example 2, we're going to show that x plus 3 is a factor of this polynomial. Then we're going to find the remaining factors of the polynomial. So this is a multi-step problem, but we got it. So here's what we're going to do. We're going to use, because I'm feeling lazy to use long division, but if you want me to do a video or talk about doing long division of x plus 3 into this thing, I can, but hopefully you remember how long division goes and you don't need to do that. But anyway, if we have to show that this thing is a factor, we're going to use that theorem. That theorem says that the value, it was x minus a, so a was the factor, it's x plus 3, so negative 3 is the factor. Negative 3 is the value we're going to plug in. So we're going to plug in negative 3, do some synthetic substitution, negative 3, or we can actually think about it as synthetic division too. It's kind of like we got a couple things going on. Let's think about it as synthetic division. We're going to divide that in there by taking the lead coefficient 1, 6, negative 1, and negative 30, just eyeballing it, making sure we're going from descending order and there's nothing missing and we're good. And I'm going to drop the 1, negative 3, positive 3, negative 9, negative 10, positive 30, and I have a 0. So this confirms that this is indeed a factor, right? X plus 3 is indeed a factor. And then you remember what we did? This is the constant term. This would have been the remainder. There is none. This is the constant term. This is the linear term, or the what I'll call the x term, sorry for the sloppy handwriting, and then this is the x squared term. So the resulting polynomial is x squared, 1x squared, plus 3x minus 10, okay? Then find the remaining factors of the polynomial. So we've already got one factor. We divided this out. This is a factor, but can we factor the factor is the question. So we're going to try to do that, hoping that we can factor this pretty simply by saying, yeah, we can. X and x here, what two numbers multiply to give me a negative 10? yet add up to give me a positive 3. And that will be positive 5 and negative 2. So if I were to factor this whole thing, f of x equaling x to the third power plus 6x squared minus x minus 30 is equal to the product of x plus 3. That's the factor we got. We divided it out. We got this, and we factored that. And x minus 2 times x plus 5. All right? And so we factored the bad boy completely. All right, so here is a kind of contrived problem, but we can do it. Find all factors of the polynomial, just a way for us to think about it again. This is another chance for us to do the same thing. It says the volume of a rectangular prism is given by v of x is equal to this particular polynomial. Find the missing measures. And so what we would do here is basically we're going to factor this thing. They gave us this measure, so we're going to divide x minus 4 into this polynomial, and we can do it by synthetic division. So I'm going to put a 4 here, right? And then I'm going to, I think that's not how we do it. Okay, this is how we do it. We do the 4 and we put it like that. I don't know why I was doing some kind of weird upside down business. Anyway, so we do that. We take the 4, we take the coefficients 1, 3, negative 36, and positive 32, making sure that we have not missed anything. And we did that. And then we drop the 1. We get 4 here, 7, 28. The difference between these two is 4, 4, 5, 6 is 6. 8. I can do math. I can do this. Okay, negative 8 should be 32. 4 times negative 8 is a negative 32. And we got a 0. Not surprising because they told us that this was one of the factors by the way they set up the problem. So next we have to recognize what is happening here. This is a constant. This is an x term and this is an x squared term. So 1x squared plus 7x minus 8. Can we factor this? Yes, we can. We know that two numbers that multiply to give me a negative 8, but add up to give me a positive 7 would be 8 and negative 1. And so I rock my x's there and I'm done. I factored it. So those are the measures of the sides, all right? I think we have done enough for you to be able to practice some of the concepts that we did here today. So I'm going to give you an assignment. Please look for it and take it easy. All right, bye-bye.